Okay, what you're going to do for this type of question here is you can create a right triangle to use as a reference for these. Okay, so if I create a right triangle as a reference here, and I assign one of my acute angles to be theta, it can be either one. Okay, if I want to find what angle has a tangent of 17/8, so theta, in order for it to have a tangent, I use the SOHCAHTOA trig ratio as opposite 17 over adjacent 8. I can create that right triangle. I can then use Pythagorean theorem to find the corresponding hypotenuse. So I would say 8 squared plus 17 squared equals c squared. If I calculate that, here I get my solution. 64 plus 17 squared is 353. Take the square root of that. If you can reduce it, reduce it. There is no reducing, so root 353 is my hypotenuse. Okay, and so now I'm asked to evaluate the cosine of this angle theta. Well, this whole triangle here represents theta. This here is theta. We use the inverse trig ratio to find it. So really what we're looking for now is the cosine of theta. Well, the cosine is adjacent 8 over hypotenuse root 353. And so that would be your answer. If you rationalize it, you get 8 root 353 over 353, and that would be your answer. Now, what if you have a ratio where it's already written in this sort of rationalized form? If you can remember what the relationship between the rationalized form and the non-rationalized form is, 12 root 313 all over 313 is equivalent to 12 divided by root 313. Okay, so you don't have to rationalize again, or you don't have to try to undo this. Just know that this quantity right here is equivalent to this quantity here. Okay, so if you were to set up a triangle using this information, assign one of your angles theta. Here you know that this all represents theta. So theta is the angle whose cosine ratio is 12 over root 313. So cosine is ca. So here the adjacent is 12. The hypotenuse is root 313. And now you can find the remaining piece by using Pythagorean theorem. 12 squared plus a squared equals root 313 squared. And if you calculate that, root 313 squared is 313 minus 12 squared, 144. That gives you 169. If you take the square root of that, you get 13. So a is technically plus or minus 13, but since it's a distance, we'll use the positive. So you found what your missing side is, and now you can evaluate the sine of this angle is opposite, so 13 over hypotenuse, root 313. And so when you write your answer, it's going to be 13 root 313 divided by 313 if you rationalize, and that would be your solution. If we use this relationship inside to identify a right triangle that fits, so we know that the sine, which is so opposite over hypotenuse, is, and again this is equivalent to 13 over root 365. So the opposite is 13, the hypotenuse is root 365. I can use Pythagorean theorem to solve for my missing side. So I have a squared plus 13 squared equals root 365 squared, which will cancel that radical. And so if I calculate 365 minus 13 squared, or 169, gives me 196. Okay, that's not necessarily a common radical or perfect power that you're familiar with, but it is 14 squared. So this can solve to be 14. So that's the length of our other leg. And now when we identify our tangent, the tangent is TOA, opposite 13 over adjacent 14, and that would be the solution.